Dear colleagues, I am very glad to be invited participant of the conference. Let me present the result of our study on the topic, the eye tracking in the study of cognitive processes. Research was conducted at the Odessa Polytechnic National University by Vitaliy Pavlenko and Tetiana Shamanina. The study of human eye movement and the trajectory of their movements reveals the structure of the relationship of the individual with the environment, man with the world. The process of acquiring knowledge is a central part of the learning process, proposed in the project method of psychological identification of the individual on the basis of experimental data using innovation eye tracking technology and computational means of the processing alone to monitor and diagnose the state of cognitive processes during student learning activities. The aim of the research you can see in this slide. It is development software tools and introduce of the received information models in diagnostic practice of state of cognitive processes. The identification process is based on the use of the test visual stimuli that are displayed on the computer monitor screen at a different distance from the starting position. On the picture you can see the diagram of the eye tracking processes. Enable support of the following 4 tasks. To describe object of unknown structure, it is advisable to use the most universal nonlinear parametric dynamic models, Volterra model. The input-output relation of a nonlinear dynamic system with an unknown structure such as a black box will one input and one output can be represented by a discrete Volterra polynomial on degree n equals 3 in the form on this slide. Eye movement tracking to identify OMS. Taking into account the specific of the studied OMS, test step use signals are used for identification. If the test signal X equals theta, where the theta is the heaviside function, then the partial components of response y first, second, and third will be equal of the transcendent function of the first order h first and diagonal sections of the transcendent function of the second and third order h second and h third respectively. In the studies of respondents, 3 experiments were performed sequentially for the 3 amplitudes for the test signal on the horizontal direction. On the slide you can see generation of test signals and the position of the dots for the screen during the experiment. The experiments were organized in order to classify substances by the state of fatigue. The data for construction the model of the OMS respondent in the same test signals were obtained using the total theorem DX13 eye tracking at different times of day, in the morning before work and in the evening after work. The average values of the OMS responses obtained for the eye tracking at various amplitudes of the test signal in the morning and in the evening are shown in figure 3. On the figures 4 and 5 you can see graphs of transition function for the state of respondents in the morning and in the evening for the model first and second order. Graphs of transition function obtained for the in the morning and in the evening state of the subject based on the model are shown in picture 6. The variability of the MTF of different orders and of the approximation model of OMS for the state of the respondent in the morning and in the evening is quantified it using the indication normalize standard deviation. To assess the psycho-physiological state of personnel based on the OMS model, studies were carried out. First, getting a feature space of building a human state classifier using machine learning. Second, building classifier using determination and statistic learning methods for pattern recognized based on the data updating using eye tracking technology. Gaussian classifiers is built for separate of two classes as a discriminant function of the form is used. This form you can see on this slide. Gaussian classifier of a personal facing state in two-dimensional feature space is provided with a maximum recognition reliability with a combination of the following features. The application of the OMS identification method based on the Volterra model in the form of multidimensional transition function using the test visual stimuli with different distance from the starting position. Step function in different amplitudes is substantiated. The information technology of obtaining experimental data from the identification of OMS with the help of the test visual stimuli and the use of eye tracking to track the corresponding eye movements has been developed. Development of the Matlab system software for the identification of OMS. Experimental studies of OMS were performed with the help of eye tracking technology, and the transition function of the first, second, and third orders were determined on the basis of oculographic studies. Classifiers of human cognitive states are built on the basis of the studies heuristic features that are residents of computational errors. The features were calculated on multidimensional transient function obtained from the integral Volterra model of the human OMS within a new approach of diagnostic human cognition. Thank you very much for your attention.